Okay, this video accompanies the 6.3 practice page test for parallelograms. So let's talk about these. In number one, they're showing us that we have a quadrilateral that has exactly one pair of opposite sides that are both congruent and parallel. That is enough information for us to know that this has to be a parallelogram, and we could prove it if we needed to. Number two, another property of parallelograms is that opposite angles are congruent. So if we can show opposite angles are congruent in a quadrilateral, then we have a parallelogram. Here we have both pairs of opposite angles congruent, so it's a parallelogram. Number three gives us exactly one pair of congruent sides. That's not enough for this to be a parallelogram. Number four, we've got two sets of opposite sides that are both congruent and parallel. That fits one of the prerequisites for a quadrilateral to be a parallelogram. So that number four is a parallelogram. If we have a parallelogram for number five, diagonals bisect each other. So they're showing us in the diagram that diagonals bisect. That's enough for number five to be a parallelogram. And for number six, we have one pair of opposite sides that are parallel and the other set of opposite sides are congruent. That's not enough for this to be a parallelogram. It might actually be an isosceles trapezoid for all we know. If we look at number seven, if we have a parallelogram, opposite angles need to be congruent. So we set the x portions equal to themselves. And if we solve for x, we get x is equal to 20, which makes those angles 56 degrees. And we do the same thing for the y's. If these opposite angles are congruent also, then we do have a parallelogram. And if y is 45, then each one of these angles would be 124. So that is a parallelogram. Number eight, I don't have the numbers that I can see for number eight, but this might have something to do with finding the slopes of these opposite sides to show that the opposite sides are parallel to each other. Number nine, if diagonals bisect, we have a parallelogram. So if this is a parallelogram, then if we solve for the y's that make these two segments congruent, we get for y equals 23, the length is 64. And if we set the x parts equal to each other, we find out for x equals a -6, each one of these comes out to be 22. So the total x diagonal length is 44. The midpoint or halfway point is 22n. And going the other way with the other diagonal, the y diagonal, the total length is 128, and each portion is 64. So the x diagonal bisects the y diagonal and vice versa. For number 10, if this is a parallelogram, then opposite angles need to be congruent. If we solve for x, set the two x parts equal to each other, we get x is equal to 20. That gives us 129 for the angle. And for the y parts, if y is 12, that gives us 51 for those.